Hello everyone, welcome back to docras.com. In the previous lecture, we discussed about the prerequisites of predictive parsing, and in this lecture, we'll go into the details of predictive parsing. Look at the agenda of the lecture. We start with the details of the predictive parser, where I'll be introducing the predictive parser, and then I'll explain about the different components of the predictive parser. We then move on to the procedure of the predictive parser, where the role played by each of the component is explained with the help of an example. The predictive parser that is discussed here is called as non-recursive predictive parser because the stack which is required for the activity of parsing is maintained explicitly in this case. We start with the details of the non-recursive predictive parser. The predictive parser is a top-down parser as we discussed in the previous lecture, and it follows a leftmost derivation. The key problem during predictive parsing is that of determining the production to be applied for a non-terminal. Let us assume we have the following productions A to alpha, beta or gamma. When we want to substitute one of the productions for the non-terminal A, we have the problem of determining whether to substitute A by alpha, beta or gamma. This problem of not being able to determine the appropriate production is being solved with the help of the parsing table in predictive parsing. There are four important components of a non-recursive predictive parser: the parsing program, the parsing table, an input buffer, and a stack. The parsing program is the one which controls the complete predictive parser. A parsing table is a two-dimensional array m of capital A comma small a, where capital A is the non-terminal and small a is the terminal, or the symbol dollar, which means end of the input string. We have the input buffer which contains the string to be passed followed by dollar. And we have the stack finally, which contains a sequence of grammar symbols with initially dollar at the bottom of the stack and followed by the start symbol of the grammar in it. This is the diagrammatic representation of the predictive parser. In this diagram, we have the predictive parsing program, which has the complete control over the parsing activity. We have the parsing table, which is a two-dimensional array. This parsing table determines the appropriate production to be used based on the input. We have the input buffer, which takes the input string and it is terminated with the dollar symbol. We have a stack which has dollar as the bottom of the stack and grammar symbols on the stack. At any point of time, the predictive parsing program compares the top of the stack with one of the input symbols in the input buffer. And finally, the predictive parser takes the input string and finds whether this input string belongs to the language or not. We now move on to the predictive parsing procedure, where the input string is taken and checked whether it belongs to the language generated by the grammar. At any point, the predictive parsing program considers X the symbol on the top of the stack and A the current input symbol. If X is a terminal, which means the top of the stack is a terminal, then we check if X is equal to A is equal to dollar, which means that we have come to the end of the input string where the entire input string is being scanned and we are at the last symbol of the input. And as far as the stack is concerned, we have finished all the symbols in the stack and we have come to the bottom of the stack. In that case, we halt and return success, which means that the input string belongs to the language generated by the grammar. If X is equal to A not equal to dollar, which means there is a match between the top of the stack and the current input symbol, then we pop X, the top of the stack, from the stack and advance the input pointer to the next symbol. This is where the pointer is going to point next. If X is not equal to A, which means there is no match between the top of the stack and the current input symbol, then we halt and return failure. Now we consider the case where X is a non-terminal. In that case, we consult the parsing table, which is a two-dimensional array, and check the entry at m of x comma a, where x is the non-terminal and the top of the stack, and a is the current symbol under consideration. If the entry at m of x comma a is a production rule, then we replace x, which is a non-terminal and the top of the stack, by the right hand side of the production. And if the entry is blank, then we halt and return failure, which means that the input string does not belong to the language generated by the grammar. Let us start with an example to understand the process of predictive parsing better. Here we are given an example grammar, and as we discussed in the previous lecture, the given example grammar is free from left recursion. The start symbol of the given grammar is E, and the input string that is given is id plus id star id. What we are going to do here is we are going to check whether the given input string id plus id star id belongs to the language generated by the given grammar or not. To do this, we have a parsing table. The parsing table plays a very important role in the activity of parsing. And how the parsing table is constructed will be discussed in the next lecture. Now we'll go into the details of the algorithmic trace of the parsing program. First, let us look at the contents of the stack and the input buffer. The stack consists of dollar and E. The dollar is the bottommost stack symbol, and E, which is the start symbol of the grammar, is the topmost symbol to start with. The reason why we take E as the topmost start symbol is predictive parsing is a top-down parsing procedure, and all top-down parsing procedures start with the start symbol of the grammar. The input buffer has the input string id plus id star id followed by dollar, which is the last symbol in the input buffer. At any given point of time, the parsing procedure compares the x, which is the top of the stack, with a, the input symbol under consideration. Here E is the top of the stack, and the first symbol in the input, which is id, is the current input symbol. Therefore x is equal to E and a is equal to id. So because the top of the stack is a non-terminal, as we discussed in the last slide, the parsing program conserves the parsing table at the location m of x comma a. Here x is E and a is id. So therefore the location that is being consulted is E comma id, where we have the production E to TE dash. So here E is the left hand side of the production and TE dash is the right hand side of the production. As we discussed in the last slide, E, the left hand side of the production, will be replaced by TE dash, the right hand side of the production. TE dash is kept in the stack in the reverse order, because t must be coming at the top of the stack. So therefore e is replaced by e dash t, and now t is the top of the stack, and id is still the first symbol and the symbol under input symbol under consideration. So therefore x is equal to t and a is equal to id. Now the parsing table is again consulted at the location t, the top of the stack, and id, the current input symbol under consideration. Here we have one more production, t to ft dash, where t is the left hand side of the production and the current top of the stack, and ft dash is the right hand side of the production. T, which is the current top of the symbol, is now replaced by ft dash in the reverse order, and therefore we have t dash f, and f is the current top of the stack, and the current input symbol under consideration is still id. So now the top of the stack is f and the input symbol is id. So therefore the parsing procedure consults the parsing table again at the location f and id, which is one more production, f to id. F is the left hand side of the production and the top of the stack, whereas id is the right hand side of the production. Therefore f, the top of the stack, is replaced with id, which is the right hand side of the production. Now the top of the stack is id and the current symbol, input symbol under consideration, is still id. Now the parsing table compares the top of the stack with the current input symbol, and we find that a match occurs with the top of the stack and the current input symbol. As we discussed in the previous slide, when a match occurs, the top of the stack is popped, and therefore t dash becomes the top of the stack, and the input pointer is advanced to the next input symbol, and plus is the current input symbol under consideration. Because t dash is the top of the stack, the parsing procedure again consults the parsing table at the location t dash and plus. Here we have a production which is t dash to epsilon. T dash is the left hand side of the production and the top of the symbol, and epsilon is the right hand side of the production. T dash, which is the top of the stack, is replaced with epsilon, which is a null string, and therefore t dash is removed and nothing is kept in the stack, and therefore e dash becomes the top of the stack now. The current symbol, input symbol under consideration, is still plus. So now we have e dash as the top of the stack and plus is the current input symbol under consideration. Therefore the parsing procedure again consults the parsing table at the location e dash and plus. So here we have one more production, which is e dash 2 plus t dash, where e dash is the left hand side of the production and the top of the stack, and plus t dash is the right hand side of the production. So e dash, which is the top of the stack, is replaced by plus t dash in the reverse direction. Therefore it becomes e dash t plus, and now plus is the top of the stack and the current input symbol under consideration is also plus. Now the parsing procedure compares the top of the stack with the current input symbol and a match is found. Because the top of the stack matches with the current input symbol, the top of the stack is popped and T becomes the top of the stack and the input pointer is advanced to the next input symbol, which is ID. Now the top of the stack is T and the current input symbol is ID. Therefore, the parsing procedure again consults the parsing table at the location T and ID. At this location, we have a production which is T to FT dash, where T is the left hand side of the production and the top of the stack, and FT dash is the right hand side of the production. The top of the stack T is replaced with FT dash in the reverse order, and therefore it is inserted as T dash F, and F becomes the top of the stack. The current input symbol under consideration is still ID. So now we have F as the top of the stack and ID as the current input symbol. Therefore, the parsing procedure again consults the parsing table at the location F and ID. And here we have a production F to ID, where F is the left hand side of the production and the top of the stack, and ID is the right hand side of the production. And therefore F, the left hand side of the production, which is on the top of the stack, is replaced with the right hand side of the production, which is ID, and now ID becomes the top of the stack. The current input symbol under consideration is still ID. Now the parsing procedure compares the top of the stack with the current input symbol and a match is found. Because a match is found, the top of the stack is popped and T dash becomes the top of the stack. And the input pointer is advanced to the next input symbol. So now the top of the stack is T dash and the current input symbol is star. Therefore, because the top of the stack is a non-terminal, the parsing procedure consults the parsing table at the location T dash and star. Here we have a production T dash to star FT dash, where T dash is the left hand side of the production and the top of the stack currently, and star FT dash is the right hand side of the production. Therefore, T dash, the top of the stack, is replaced with star FT dash in the reverse order, and therefore the string is inserted as T dash F star, and star is the current top of the stack, and star is also the current input symbol under consideration. Now the parsing procedure compares the top of the stack, which is star, with the current input symbol, which is also star. And because a match is found, the top of the stack is popped from the stack, and now F becomes the top of the stack, and the input pointer is advanced to the next input symbol, which is ID. Now the top of the stack is F and the current input symbol is ID. Because the top of the stack is a non-terminal, the parsing procedure again concerns the parsing table at the location F and ID. And here we have a production F to ID. F is the left hand side of the production and also the top of the stack, and ID is the right hand side of the production. F, the top of the stack and the left hand side of the production, is replaced with ID, the right hand side of the production, and ID becomes the top of the stack. And the current input symbol under consideration is also ID. Now the parsing procedure compares the top of the stack with the current input symbol under consideration, and a match is found. Because a match is found, the top of the stack is popped and T dash becomes the top of the stack. And the input pointer is advanced to the next symbol, which is dollar. Now T dash is the top of the stack and dollar is the current input symbol under consideration. And because T dash is a non-terminal, the parsing procedure consults the parsing table at the location T dash dollar, which is a production T dash to epsilon. Here T dash is the left hand side of the production and the top of the stack, and epsilon is the right hand side of the production and a null string. Therefore T dash, the top of the stack, is replaced with epsilon, the null string. Therefore nothing is inserted into the stack and E dash becomes the top of the stack, and dollar is still the current input symbol under consideration. So now E dash is the top of the stack and dollar is the current input symbol. Therefore the parsing procedure consults the parsing table again at the location E dash dollar. So at this location we again have a production which is E dash to epsilon. E dash is the left hand side of the production and the current top of the stack, and epsilon, the null string, is the right hand side of the production. Therefore E dash, the top of the stack, is replaced by epsilon and nothing is inserted into the stack. Now dollar is the top of the stack and dollar is the input symbol under consideration. Because dollar is the top of the stack and dollar is the inputs under consideration, we have the case where x is equal to a is equal to dollar. As we discussed in the previous slide, when we have the case where x is equal to a is equal to dollar, we halt the procedure and return success, which means that the input string under consideration, which is id plus id star id, belongs to the language that is generated by the given grammar. In this lecture, we discussed about the different components of the predictive parser and the procedure of the predictive parser with an example. In the next lecture, we shall discuss about the construction of the predictive parser. Please visit docross.com for the lecture notes and PowerPoint presentation of the current lecture. Thank you.